In this video, we will look at the problem with plastic consumption, or overconsumption, as well as plastic recycling, which in the United States and in Europe got much more complicated in 2018. At the global level, plastic pollution has become a massive issue. There's now a giant Pacific Ocean garbage patch filled largely with plastics. Anyone who spends time near the ocean knows how much plastic pollution washes up and collects on beaches. And in this picture, taken in a small village in Niger, which is one of the world's poorest countries, you see plastic everywhere. So for both rich countries and poor countries, plastic overuse and pollution, combined with this challenging problem of recycling, has made this material one of the largest global waste management problems that we face today. The objectives for this video are to explain what plastic is made of and what the different numbers on plastics mean, because that corresponds to composition. Many of the problems in plastic recycling come down to this issue of chemical composition and usability. We'll then look at why some types of plastics are recyclable and some are not. And we'll talk about the current state of plastic recycling in the US, where we're facing a number of challenges that we have to address if we want to divert more plastic from the landfills. The first thing to understand about plastics is that they're made from hydrocarbons, which are long chains of carbon and hydrogen atoms. However, not all plastics are the same, so if we look here at the plastic called polyethylene, and that, by the way, is labeled on water bottles and other products as PE, we see that polyethylene has a hydrocarbon chain that's very simple and is made up of repeating structures of one carbon and two hydrogens. The little n in the diagram here tells you that it repeats over and over again. Most plastics are made from hydrocarbons that are derived from oil, but they look different. So like the next plastic over, polypropylene, is also made up of a repeating structure of hydrocarbons, but with the CH3 or methyl group in place of one of the hydrogens. As you can see from these other structures, there are a number of different types of materials that are used for plastics. All plastics have some sort of repeating hydrocarbon base, but the composition varies by the type of plastic that's used. Polyvinyl chloride contains a chlorine in place of the hydrogen, and polytetrafluoroethene has fluorines instead of hydrogens. All of this is important because the chemical composition of plastics influences how they're recycled and whether they can be used in new products. When you look at the plastics of materials that say you purchase in a grocery store, you see a number on that container that refers to the chemical composition of the plastic in the material. A number 1 plastic is a polyethylene, terephthalate. A number 2 is a high-density polyethylene, or HDPE. Number 3s are polyvinyl chlorides. Number 4s are low-density polyethylene. Let's pause there for a second, because low density implies something about the composition of the material. In this case, that it's relatively light and potentially flexible. And this is in fact what plastic bags and food wraps are often made from, these LDPEs. Number 5 is polypropylene. Number 6 is polystyrene. Everything else is given a number 7. As you can see from this image, these plastics have different properties, and they have different capacities for recycling. Now, whether a plastic is recyclable or not depends on the recycling capacity and technology in your community. In many or most places, only rigid or relatively large pieces of plastic are recyclable, and those tend to be the number 1s, the number 2s, and the number 5s. It's very rare that you can recycle the softer and more flexible types of plastic, but it is possible. For example, some grocery stores collect plastic bags made up of low-density polyethylene, or number 4 plastic, and ship these off to special recycling facilities. So here's the problem with plastics. The first issue is that we keep using more and more of it. Globally, plastic production has been increasing about 3 to 4% per year, which is much faster than the growth rate in total human population. The highest per capita production rates for plastics are in the European Union and the United States. And up until just a couple years ago, the US and other wealthy countries shipped their plastic waste, collected in the recycling stream, to China for processing. China banned this practice in 2018, and a number of other countries with plastic recycling facilities are now following suit. So what this means is that in the US and Europe, countries are no longer can outsource the recycling of plastic and are now working to develop their own recycling capacity. As that occurs, takes time, and some municipalities have had to divert plastics from the recycling stream to the waste stream that ends up getting buried in sanitary landfills because the capacity just simply does not exist in these countries yet. The second issue with plastic recycling is that the different types of plastic have to be separated to be able to effectively reuse them in new products. You can't be mixing high-density polyethylene plastic with a polypropylene plastic if you want to be able to create a new product from the material. So that means sorting the plastics, either by hand as is seen in this picture, or increasingly by advanced machinery that's able to scan and sort the plastics as they move down a conveyor belt. Of course, all of this adds to the cost of plastic recycling, and it means that it's difficult to make recycling more cost-effective, especially if the price of oil is low, because oil is where new plastics come from. So before we look at a few common household plastics in the next slide, it's worth noting that the less plastic you use is the less you'll have to recycle. And right now in the United States, that's the best way to keep plastic out of the landfill. So let's now take a look at some of the plastics that are common in a household setting and see what's recyclable and what's not. Let's start with a beverage bottle, in this case, a chai bottle. This is a number 5, recyclable in most cases, but what about the cap? Looks like it might be a different type of material. Got to take the cap off, because the point is these are probably different types of plastics. In fact, I don't even know what this cap is. So if you're going to recycle a bottle like this, take the cap off first. Yogurt container, also a number 5, also recyclable. A little more flexible, pretty easy to turn into a new product. Plastic wrap. Here's your low density polyethylene. Recyclable? No, for 2 reasons. One, because of the material. The second is that this tends to clog up the sorting lines that are present in the recycling plants. So unfortunately, best thing you can do with this, toss it out. How about this? A little plastic bag wrapping up some sponges. LDPE, low density polyethylene, non-recyclable. Last one, water bottle. Interesting, very rigid, probably a couple different kinds of plastics on here. Let's take a look and see what it is. It's BPA free, that's good. And it's a number 7. We have no idea what this plastic is. Not recyclable. So before you throw something out, have a look, see what it is, make sure it's recyclable in your community. To summarize this video, you should now know that the different numbers on plastics refer to specific chemical compositions. These compositions determine whether or not a plastic can be recycled and reused for new products. This is partially because the structure determines the properties of the plastics, including characteristics such as being flexible or rigid, opaque, or transparent. Starting in 2018, it was no longer possible to send plastics to China for recycling, and so this is now forcing the US and European countries to develop their own plastic recycling capacity. Until this occurs, the best way to deal with plastic pollution is to just try not to use as much.